Hello everyone. We are going to discuss the hypothesis tests in this lecture. Hypothesis testing is carried out to determine the statistical significance of any proposed model, of any model designed, mathematical model designed for any research purpose. Now, the models that we design, we need to understand that how much significant it is, whether it is happening by chance or whether it is really statistically significant. So certain terms come here when we go for hypothesis testing, such as significance level, then confidence level, then p-value. Okay, and for conducting these hypothesis tests, we go for different kinds of statistical significance tests. Like one can be a t-test, and there can be a z-test. Let's begin with the z-test. So z-test and the t-test, these are the commonly used significance tests, but we have to understand which test to apply at what scenario. For example, when the large sample size, we are having a large sample size, rather we can say that when it is greater than 30, in that case we go for a z-test. And also another condition needs to be satisfied, that is we have to have a known population standard deviation. Mind it, is known population standard deviation, not sample standard deviation. It is population standard deviation. Okay, for example, when we are, if we are testing whether the average height of students in a university is significantly different from a known population average height mu naught, for such kind of testing, we collect a large sample of student heights and use a z-test to compare the sample mean to the population mean. So if we have, so the sample mean may be biased or it may not be biased, right? Now the null hypothesis, in this testing, there are two kinds of hypothesis. One is null hypothesis and another is alternative hypothesis. The null hypothesis states that the population mean is equal to a specified value. So mu equal to mu naught. Mu naught is my what? It is a from a known population average height mu naught, and it assumes that the this and my alternative hypothesis is mu not equal to mu naught. That is population mean is not equal to a specified value. So null hypothesis assumes that it is happening by chance. That is the sample value that the mean that I am getting, if it is equal to the population mean, so that is happening by chance. Whereas if it is different, or it is the result is statistically significant, that is being explained by the alternative hypothesis. Either of these has to be true. Next comes the t-test. T-test is used, there are different types of t-test. First is one sample t-test, next is independent sample t-test, and the third is paired sample t-test. Okay, now under one sample t-test, if you see, it is used when we have a small sample size but we do not know the population standard deviation. First case is, it is having a small sample size, as well as we do not know the population standard deviation. That is, the sample standard deviation may be known. It assumes that the data are approximately normally distributed. So in this case, we use a one sample t-test. Okay, we want the test whether the average time spent on a certain task by a sample of individuals is significantly different from a known standard time. So in this example, our null hypothesis is again that population mean is equal to a specified value, whereas the alternative hypothesis is mu is not equal to mu naught. That is, population mean is not equal to a specified value. So this is the case where we apply a one sample t-test. Okay, again, independent sample t-test. Independent sample t-test is used when we compare the means of two independent groups. it assumes that both samples are approximately normally distributed. Example is, we want to compare the average test scores of students who attended two different teaching methods to see if there is a significant difference. Okay. Again, here null hypothesis is that means of the two groups are equal, and the alternative hypothesis is means of the two groups are not equal. Like, say for example, in an independent sample t-test, let's give an example from the concept of deep learning. Say we are using two different models, say an LSTM model and a GRU model on the same data, and we want to see that which model is performing better. So say the LSTM model performs better than the GRU on certain sample data. Okay, now how can we say that this LSTM model is better than the GRU just by performing an accuracy test? And we cannot simply say that it is better. We, in order to authenticate our result, in order to understand that what result we have obtained is statistically significant and is not a biased one, we need to perform an independent sample t-test here. So there we go for this independent sample t-test. Okay, next is a paired sample t-test. In the paired sample t-test is used when we have pairs of related observations, and we want to test if there is a significant difference. Example is, we measure the blood pressure of the same group of individuals before and after a treatment to see if there is a significant change, right? So there are many blood tests are also carried out before your lunch and after your lunch. So before taking food and after taking food of the same individual. So if there is a difference, the main difference is equal to zero, that is the null hypothesis. And if it is not equal to zero, that is the alternative hypothesis. Now to summarize, we use the z-test for large samples with a known population standard deviation. We use one sample t-test for small sample sizes or when population standard deviation is unknown. Again, we use independent sample t-test when comparing two independent groups. We use paired sample t-test when comparing two related groups. Okay, so please keep these things in mind, which significance test to apply in order to test the statistical significance of your model, of your research outcome. Okay, so summarizing further, this is like when to use which table, t table or a z table. So if we know the population standard deviation, if it's a no, then directly we go for a t table. If it's a yes, we again have to further get the answer for this question if the sample size is greater than 30. If it's a yes, then again we use a z table, and if it's a no, we revert back to t table. Okay, so this is the case of using the different hypothesis tests, whether it is should be a z test or a t test, and which kind of, if it is a t test, which kind of t test to be used. Okay, thank you.